Hello and welcome to another YouTube video. This is Cracking the Cryptic app, Fog of War pack, puzzle number 6, Toastie. The rules are: Fog of War. Correctly placed digits clear the fog around them. Then, Classic. Every row, column, and box must have all numbers from 1 to 9 exactly once. Sandwich. The numbers outside each row and column correspond to the sum of the numbers between 1 and 9 in that row or column. And lastly, Thermometer. Numbers must increase as they move along thermometers, starting at the bulb. There is also a custom rule saying that thermometers do not overlap or share bulbs. Without further ado, let's begin. First, let's clarify what the sandwich rule really means. Basically, for example, if this digit was a 1 and then this digit was a 9, that would mean that these numbers between them sum up to 16. And the same thing is true for columns. And with that clarification, we can start with an observation. Since the custom rule said that thermometers do not overlap or share bulbs, that means that this cell right here, as well as these cells, they cannot be bulbs. They must be bodies of one and the same thermometer. So if we start counting from this cell, which is part of the thermometer, 1, 2, 3, 4, 5, 6, 7, 8, 9, we see that we are actually given the shape of the full thermometer, and that we're here. These are the far ends of the thermometer. So these are the 1 and the 9. Obviously, we don't know the position of them. We don't know what is the top and what's the bottom. But regardless of that, we also know that no matter how we start counting, the 2 is either here or here, and then the 3 is either here or here. And same with the 4, until they meet up with the 5 over here. And then we also see that when we click on the 16, it first of all creates this weird line. We can ignore it. But it shows us on the top right of the screen all the possible values that could add up to the 16. And since we know that it's not 3 digits long, not 4 digits long, we can get rid of those top 2. And since we know that it must contain a 5, it's either 358 or 457. So first, let's try the 358. So this or this could be either 3 and 8 or a 4 and 7. All right, so how far did we get? We got to the 5, right? So let's continue counting the thermometer. This or this is the 6, no matter if we start counting from here or here. Then this or this is the 7. And lastly, these are the 8s of the thermometer. Before continuing, let's fill in every other possible value of this Sudoku. And then we are going to place the first value, which we have deduced is the 5. 7, 8, and 9. So we know that this must be the 5. Now, keep in mind that no matter how you start counting, the 4 and the 6 are here, right? So that means that the 4 cannot be down here. And for the similar reason, 3 and 7 are up here. So this cannot be either 3 or a 7. And that means that this value must be the 8. And since we have 8, 5, that means that this must be a 3. All right. Since we placed the 8, this resolved into a 2, giving us that this is the indeed the bulb of the thermometer. And now we can fill in the rest of the values. All right, perfect. Now this is the 9. And this revealed 2 new thermometers to us. Well, 3 new thermometers with this one as well. So we know that this cannot be a 1, because that's the end of the thermometer. And this cannot be a 9 since that's the beginning. And this cannot be a 1 either because it's the body of a thermometer. So how do we proceed? Well, we are in this row and a 9 was revealed to us. And we know that the distance between a 9 and a 1 is at least 14. So that means that this thing over here cannot be a 1 because it would have 0 distance between 1 and 9 and not 14. And same is true here. This cannot be a 1 either because it's just one digit. So it cannot be a 14 distance. What about this? So if a 1 was over here, it will be 2 digits away from the 9. But if it's 2 digits away, that means that it has to be a 6 and an 8. But an 8 cannot be there because the 8 is down here. So there will be no way to make the 1 14, 14 away from the 9, which doesn't work. So therefore, the 1 must be somewhere down here. And since 8 and 4 give us 12, that must mean that this is, in fact, the scenario in which 2, 4, 8 is the distance between the 9 and the 1, making this a 2, and therefore a 1 over here. Okay. Now, since this is a free, that must mean this cannot be a 2 or a free. And so 3, 4, 8, 9 and 4, 8, 9 give us a quadruple, meaning that this cannot be 3, 4, 8, or a 9. It resolves into a 1, 2 pair, but this is already clean. And yeah, it's not immediately obvious what to do next, because I don't think we have enough digits to make any grand conclusions. So since a 3 is here, that means that a 3 cannot be down here. Four. Okay. And then 5. 6, 7, 8, and then 9. Okay. So what we notice is that when it came to 1s and 9s, especially 9s, they're kind of far apart on this end, right? There is no 9 anywhere here. That means, and when it comes to the 12 means that the 1 and the 9 can only be 2 or 3 cells apart. So basically, if you place a 1 down here, there will be no way to have a 9 2 or 3 cells apart from it. So this cannot be a 1. What about the top side? Does that work the same way? 2? So yeah, if you place a 1 up here, the 9 has to be 2 or 3 cells away from it, but it's not, so that doesn't work. What about here? So 2 cells and the 9, 3 cells and the 9. Does that work? So if a 9 is here, if a 1 is here, 1, 2 cells, this is not a 9. 1, 2, 3 cells, and this is not a 9 again, so a 1 cannot be up here either. How about here? 2 cells and a 9 doesn't work. 3 cells and the 9, that also doesn't work. But wait. So this is the case we were considering, right? So 2 cells and a 9 don't work. 3 cells and a 9 doesn't work. And top side, you don't have a way of going more of fitting the 9. So 2 cells and a 9 doesn't work, and 3 cells and a 9 doesn't work. So this cannot be a 1. All right. This works for sure, because 2 cells and a 9, that already works. And it also works with the 3 cells and a 9 down there. This thing, 2 cells and a 9, same with the 3 cells. 2 cells, 3 cells and 9, that also works. What about this one? 2 cells and a 9 doesn't work, but 3 cells and a 9 does work. So we can't get rid of anything more on the right hand side. That's a shame. What about down here? Let's check the 14. So 1 and the 9. So immediately we realize that a 9 cannot be down here because this is the body of a thermometer. So a body cannot contain a 9 unless that's where the thermometer ends. And this isn't where it ends. So okay. That makes sense. So if, that's a bit hard to explain in words, but if a 1 was here, that would mean that the 9 is at least 2 digits away from it, and at most 4 digits away. So if it was 2 digits away, the 9 would be here, right? But it's not. So that means that this cannot be a 1. It also cannot be a 9 for the same reason, because a 1 would have to be at least 2 digits, 3 digits, or 4 digits away from it. But as you can see, in all of those scenarios, there is no 1 or 9 here. So that means that this cannot be a 1 or a 9. And that's true in both scenarios. So even from this side as well, right? There's no 1 or a 9 here, 1 or a 9 here, or a 1 or a 9 here. What about this? I think we can immediately rule out the 6-8 case because, simply put, there's no way to have it 1 and a 9, just 2 of them away. It's always going to end up with this or somewhere here, and there is no 1 or a 9 in between. So 6-8 doesn't work. Let's assume that they are 3 digits away. Let that be our first assumption. So if they are 3 digits away, it cannot start from here or here, because if it starts from here, 3 digits away, it would fall here. If it starts from here, 3 digits away, it would fall here. That doesn't work. So if they are 3 digits away, then the 1 and the 9 are exactly in the selected digits. So let's check which values will work here. Let's first assume that it is 248. That doesn't work because in between, like right here, we don't have a 248. So that doesn't work. 257. Nope, there is no 2 again. 347. Oof, okay. So 3, we have a 3, we have a 4, and we do have a 7, but they are not in the right order. This is a thermometer line. So since this is the only 3, and there is no 4 here, if you place the 3, 4, 7, that would break the thermometer. And that's why that value also doesn't work. 356 though, it seems like it works because you can have a 3 here, 5 here, and then 6 here. That seems like it works. Lastly, let's check the big 4 value. So 2, 3, 4, 5 is the big value. And we make an observation again. It's that if it's 4 values long, there is no 1 or 9 here. That's what we already concluded. It must start from here, 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 or here. But it must include this middle gap if it's 4 values long. And if it starts from either of these two, if it starts from either of these two, so if one of these two is a 1, then we know that there could be no way that it's 2, 3, 4, 5 because neither here nor here is there a 2. So it doesn't start from here or here. If it's 4 values long, it must start from either of these two. And let's assume that it starts from the left, that this is the 1, this is the 2, but there is no 3 here. So if it starts from here, there's no way you can do 2, 3, 4, 5 in this direction because of the thermometer or how it's facing. So that doesn't work. So instead, let's assume that this is the 1, this is the 2, this is the 3. You have a 4 and a 5, but again, they're in the wrong order. So you would have a 3 here, 4 here, and a 5 here breaking the thermometer. So that also doesn't work. The only value that worked was the 356, and that means that this must be the 1, 3, 5, 6, and then this is the 9. So this is the 1, 3, 5, 6, and that's the 9. Okay, that was quite cool. All right. This created or opened 2 new possibilities with 2 new thermometers, and we have to get rid of the bad values. So this cannot be a 2, obviously. Can it be a 4? 4, 3, 2, 1, 0. Nope, it cannot. So that is a 7, 8, meaning that this cannot be an 8. So this cannot be a 9 or an 8 or a 7. 6, 7, 8 cannot be here. And then this cannot be 6, 7, 8, or a 5. Alright, so this cannot be a 2 or a 3. 2, 3, 4 cannot be here. So this cannot be 2 or a 4. So this is a 7. And then this is the 8. Alright. We have a 2, 4 pair over here, meaning that 2 and 4 cannot be there. Right. What do we do next? Let's slowly go through the values just to make sure. Okay, so we have a thermometer here that we haven't cleaned up yet. So 8, 7, 6, 5. Oops, 8, 7, 6, 5. 8, 7, 6, 5, 4. Sorry about that. 8, 7, 6, 5, 4. So this cannot have a value greater than 5 because it would be 5, 6, 7, 8, and 9, and there's no 9 here. So this cannot have a 5, 6, 7, or an 8. This cannot have a 3. Wait, it can have a 3. This cannot have 7 or an 8. So 6, 7, 8, 9. No, it cannot also have a 6. So this cannot have a 7 or an 8, and then this cannot have, so 5, 6, 7, 8, this cannot have the 8. Okay, so when it comes to lowest values though, this cannot be a 1 and a 3, this cannot be a 3 or a 5, and this cannot be 3, 5, or a 6. All right. That means that the 1 is here. That's the only square for the 1. What can we do? So a 1 is somewhere here, meaning that a 1 cannot be here. So that is the 5. So that's the 4. And then this is the 3. 6, 2. Making this 5. 9, 2. 3, 5. This is a 6, 7. Okay, so since a 7 is here or here, that means a 7 cannot be up here. Interesting. So let's check the rest. 8 and then a 9. All right, so let's go back to the ones. A 1 is either here or here, and we know that let's assume first that this 1 that is right here is at least, let's assume that it is exactly 2 digits away from the 9. Since a 9 isn't down here, it must go these 2 digits, and then this must be the 1 and the 9, the 9 being the one up there. So that means that it's either 4 and 8 in between, or that it is a 5 and a 7. But there is no 7 in between, and there's no 8 in between. So that means that this must be false. A 1 cannot possibly be here. So this isn't the 1, and then this one down here is the only other possible place where a 1 can be. And again, it cannot be only 2 digits away from the 9, because there is no 8 or a 7 in between, meaning that it must be 3 digits away from the 9, so the 9 is here. And then there is no 3 here, so it's not this or this. It must be 2, 4, 6. All right, that makes this a 7. It's a 4, 6 pair here, so 4, 6 isn't here. What else? This cannot be a 1, and it cannot be a 3 either, because if this was a 3, it would be surrounded by higher digits on both sides, and it's on a thermometer, so this has to be an 8. And now we see that this is connected to this, so this cannot be a 9, and it cannot be an 8, so it's a 4, making this a 3. So this is a 3 and a 1, so that's a 1. This is a 6, 7 pair, so that's a 2, 5. There's a 6, 7 pair up there, so this cannot be 6 or 7. So this is an 8, 9, 7, 7, 6 and an 8, and a 3 and a 5. So this is a 2-4 pair. 2, 4, making that one a 3. So this cannot be a 9, it's a part of the thermometer, or a 1. So 3 and then 2, 4, and then 6 is the lowest value, so 6 cannot come up here. Okay. So 1 has to be here. So it's here and then here, making that a 5. This is the 2. Alright, so let's check the 4. 5 must be here, and then 6. Alright, 7. 8. 9. Oh, okay. So this cannot be a 2. So this has to be a 4. And then this is a 2. So this is a 4. Making this a 2. 4, 6, 2. This cannot be a 7, because this digit will be greater than it. So this has to be a 9. 8, 9, and I think that's it. I think it's going to resolve itself very soon. And we are more or less very done. Okay, that was a really fun puzzle. I hope you guys enjoyed, and see you in the